The human body is a fortress designed to keep out invaders. Our skin, a formidable barrier, is our first line of defense. But even the strongest fortress can be breached. A minor cut, a tiny scrape, these seemingly insignificant injuries can open the gates to a microscopic enemy, bacteria. These single-celled organisms are everywhere, and some are opportunistic pathogens, waiting for a chance to invade. Once inside, they multiply rapidly, seeking to establish a foothold. The battle for our bodies has begun. The body is quick to recognize the invasion. Damaged cells release distress signals, chemical cries for help that alert the immune system to the danger. These chemical signals act as an alarm, summoning the body's defenses to the site of the breach. The immune system, a complex network of cells and processes, is armed and ready to respond. The immediate response is the innate immune system, a rapid, non-specific defense mechanism. It is the first wave of the body's counterattack. Among the first responders are macrophages, large white blood cells that patrol the body, engulfing and destroying foreign invaders. These cellular scavengers are drawn to the site of infection by the chemical signals, where they begin to devour the invading bacteria through a process called phagocytosis. Macrophages can consume a significant number of bacteria, but they are not a permanent solution. They are soon joined by neutrophils, another type of white blood cell, even more numerous and deadly than macrophages. Neutrophils are short-lived but powerful, releasing toxic chemicals that destroy bacteria. They are the suicide bombers of the immune system, sacrificing themselves in the process of eliminating the threat. This inflammatory response is a crucial part of the innate immune response. It causes blood vessels to dilate, increasing blood flow to the area, and leading to the characteristic redness and swelling associated with infection. This increased blood flow brings with it more immune cells and vital supplies to the battleground. While the innate immune system fights the immediate invasion, a more specialized force is being assembled, the adaptive immune response. This branch of the immune system is slower to act but far more precise. It targets specific pathogens and creates a memory of the encounter, providing long-lasting immunity. The key players in this sophisticated defense system are dendritic cells, T helper cells, and B cells. Dendritic cells act as scouts, collecting fragments of the invading bacteria known as antigens. These antigens are like fingerprints, unique to each pathogen. The dendritic cells then travel to the lymph nodes, the body's immune system headquarters, where they present the antigens to T helper cells. T helper cells are the generals of the adaptive immune response. When a T helper cell encounters an antigen that matches its receptors, it becomes activated. This activation triggers the T helper cell to clone itself, creating an army of specialized cells to fight the infection. Some of these cloned T helper cells differentiate into effector T helper cells, which release chemical signals that direct the immune response. Others become memory T helper cells, providing long-term immunity. Effector T helper cells activate another type of immune cell, B cells. B cells are antibody factories, capable of producing massive amounts of antibodies, specialized proteins designed to target the specific bacteria causing the infection. These antibodies act like guided missiles, binding to the bacteria and marking them for destruction by other immune cells. The combined forces of the innate and adaptive immune responses are usually enough to overwhelm the bacterial invaders. Macrophages and neutrophils continue to engulf and destroy bacteria, while antibodies neutralize the threat and mark them for elimination. As the infection subsides, the body begins to heal. The inflammatory response lessens and damaged tissue is repaired. Most importantly, the adaptive immune response has created a lasting memory of the encounter. Memory T and B cells remain in the body, ready to respond quickly and effectively should the same bacteria ever attempt to invade again. This immunological memory is the basis for vaccines, which introduce a weakened or inactive form of a pathogen to prime the immune system for a future attack. Thank you for joining us on this incredible journey through the human immune system. If you enjoyed this video and want to learn more about the wonders of the human body and beyond, make sure to subscribe to MindVoyage on YouTube. Hit the bell icon to stay updated with our latest videos and never miss out on new content. Join our community of curious minds and embark on a journey of discovery with us. There's so much more to explore, so don't miss out. Subscribe now. Thank you for watching, and until next time, stay curious.